Ever wanted to know how the state climate office actually measures weather and climate? Well, behind me is an ECONet tower, and we have them all over the state. Come with me and we'll talk about the sensors that we use to measure weather. All right, let's start our tower tour at the very top of the tower. Our towers are 30 feet tall, and they have what we call a propeller anemometer at the very top. This anemometer measures wind speed and wind direction. Now we have two of them on our tower. We have one at 10 meters high, which is our official measurement for wind speed and wind direction, as well as 6 meters above the ground, which is helpful for fire weather forecasting and diagnostic purposes. Okay, at 2 meters, we have a bunch of instruments, but I'm gonna start with these two right here. Both of these measurement instruments measure temperature and relative humidity. The big difference is that the all-weather sensor here measures barometric pressure, precipitation, wind speed, and wind direction. So this is called an all-weather sensor, whereas this sensor just measures temperature and relative humidity. The reason why we keep both of them here is so that we can compare temperatures, basically have multiple measurements at the same site. This is important just in case one sensor goes bad, we can rely on the other sensor for our temperature and humidity measurements. All right, we've talked a lot about weather measurements that are very basic, that most weather stations measure, but what makes our weather network unique is that we measure radiation, total solar radiation and photosynthetically active radiation. How do we do that? We have two sensors located right here at 2 meters above the tower. One's called a pyranometer, which measures total solar radiation. The other is a quantum sensor, which measures photosynthetically active radiation. This is very important for especially agricultural users who want to know how much radiation is coming in to benefit their crops. So you're probably wondering what this is. All of our stations have these, and they're known as leaf wetness sensors. And these leaf wetness sensors are very important for agricultural users as well, because a lot of their crops, diseases are very rampant when there's a lot of moisture on the leaves. So what we do at all of our sites is we measure how much the leaves are actually measuring in terms of moisture, and then we can alert our agricultural users, hey, you may want to spray to make sure they protect their crops and keep growing the great crops that this state does. All right, so how do we measure precipitation? This is a tipping bucket rain gauge, and we keep it off the tower about 5 to 10 feet, mainly so that rain that does fall on the tower doesn't accidentally fall in our bucket and give us increased precipitation totals. So how does this work? It looks kind of weird. You're not really sure how you're able to measure rain using this. It uses what we call the tipping bucket principle. So basically what happens is as rain falls, it's going to fall into a funnel that's located at the top of the gauge here. And as the water goes through the funnel, it'll drop out. Inside the gauge here are two buckets. So when one of the buckets fills up with water, it's going to tip over. And as it tips over, it records 1/100th of an inch of precipitation. And then as it tips over, it drains the water out through the bottom of the gauge. This is what we use to measure precipitation. All right, I've shown you every sensor that we measure above the surface, but did you know we measure two things beneath the surface, soil moisture and soil temperature? We use, see if I can reach it here, there we go. This is our soil moisture measurement. At 20 centimeters below the surface, or about 8 inches, and it helps agricultural users as well understand how much water is getting to their roots of their crops. But we also measure soil temperature. We measure it at 2 levels. One is at 10 centimeters, about 4 inches below the ground, and this is the instrument right here, very top right here. It's a thermistor that measures soil temperature, but we also measure soil temperature at 4 levels using our own in-house designed soil temperature sensor. This measures it at 10, 20, 30, and 40 centimeters below the ground, and this is very important to understand kind of the thermal properties or the temperature zones of the soil. This also helps out a lot during winter weather events for the kids. If they want to know, hey, is snow going to stick to the ground? Soil temperature is a great way to measure if the snow is going to stick to the soil, and your kids may get a snow day. So I've shown you everything we measure. Now the question is, how do we get that data? Well, in this white box right here, we have a few electronic gadgets that will help us record what we measure. This is known as a data logger. And a data logger basically takes all these instruments and records the data that's coming from them. We record it every 1 minute and transmit it every 5 minutes. Now here at Lake Wheeler, we use VHF radio to transmit the data back to our office in Raleigh. We do that every 5 minutes. How do we keep things powered? Well, we have a couple of batteries that keep it powered through AC power. Most of our sites use solar power, so these batteries are very useful at night when there's no sunlight to power the sensors. So you're probably wondering, you're here, you see all this fun stuff, how can I get the data? Well, at each one of our sites, we have a sign right on the tower that talks about our sensors in general, as well as a way to get our data. If you have a smartphone that has a camera or a QR link capabilities, you can just scan the QR link and it'll take you straight to our mobile page where you can get up-to-the-minute data for the station of your choice. Thanks for stopping by and taking a look at our ECONet tower and take part of this tour. If you want more information or to get data from any of our ECONet sites, please check out our website at climate.ncsu.edu.